L'Hopital's rule, example 1, part B, all right? So again, we established that in order to apply L'Hopital's rule, in order to prescribe L'Hopital to a patient, you need to check to see if your limit is indeterminate. It also needs to be mentioned that L'Hopital's rule only applied to limits being applied to fractions, which is the case here. If we put infinity in for x, see, infinity to the fifth power is infinity. So, add 7, whatever, do all the other operations. But if you take infinity to a power, you're going to be infinite. And so that denominator would be considered an infinite value. Same thing upstairs, infinity squared. What's that? Infinity. So we're dealing with an infinity over infinity. So indeed, this would be considered indeterminate. And so you go, yep, this patient, this limit is indeterminate. I'm going to prescribe L'Hopital. And so therefore you go through and you take the limits of the numerator and denominator individually. 14x minus 15x to the fourth plus 3, and the minus 1 disappears. By the way, let's keep track of that. When we prescribed L'Hopital here, the derivative of that constant fell out of the problem, didn't it? And so the minus 1 ended up not really mattering, and we'll talk about that as we move on. This denominator would be 20x to the fourth minus 18x squared minus 18x. Let me double check that again. These are easy derivatives, right? Just take the derivative of the top, take the derivative of the bottom. Notice that the plus 7 ended up falling off the question because its derivative was 0, wasn't it? Okay, so then you come back and you say, all right, well, what happens if you put infinity in for x? What's 14 times infinity? Well, that's infinity. And infinity to the fourth power is infinity. You know what? This thing is still indeterminate. So this patient, you give them 1 dose of L'Hopital, and they come back and they go, hey doc, I think I'm still indeterminate. So you check them out, you notice that they're still indeterminate. So you know what? If it remains indeterminate, you might have to apply the rule more than one time. If that new limit is still indeterminate, give it another dose of L'Hopital. All right? So you're like, okay, yeah, you're still indeterminate. Let's give you another dose of L'Hopital. So you take the derivatives of these. That'll be 14 minus 60x to the third power. By the way, the plus 3 falls off, doesn't it? And didn't that plus 3 track back to the 3x back here? It turns out that 3x didn't matter in the way at the beginning, did it? Notice some of these terms, after you keep taking derivatives, ultimately kind of fall out of the question, which is related to something we did earlier in the semester. All right, and then this one would be 80x to the third minus 36x minus 18. Take the derivatives of the numerator and denominator individually, not the quotient rule. Don't complicate the issue. Derivative of f of x, derivative of g of x. All right. When you put infinity in for x, that infinity cubed is still infinity, and infinity cubed is still infinity. Hey doc, I know you've given me L'Hopital twice, but I think I'm still indeterminate. Yep, you are. You're still infinity over infinity. Looks like we'll give you another dose of L'Hopital. So we got the limit as x approaches infinity. And again, you take the derivatives. 14 disappears, doesn't it? By the way, the 14, let's backtrack. The 14 came from the 14x, which came from the 7x squared. I always like to go back to the very original integral and talk about what terms ended up actually mattering here. But the 14's gone. Let's see, that'd be negative 180x squared. And what happens down here? That would be 240x squared minus 36. And note that the minus 18 has a derivative of 0. It disappears. It came from the minus 18x, which came from the negative 9x squared, clear back here, didn't it? So I'm crossing out way back there which terms, each time you take a dose of L'Hopital, which terms just kind of ended up not really mattering, right? Okay. Hey doc, I'm not feeling very well. infinity squared is still infinity, and infinity squared is still infinity. And, hey doc, I'm feeling indeterminate. Can you give me more Lopetal? Yeah, I guess, yeah, we better give you another dose. So here we go again. We take the derivatives of these two terms. That would be negative 360x. This would be negative 480x. And by the way, the negative 36 falls off. Let's backtrack. The negative 36 came from the negative 36x, which came from the negative 18x squared, which came from the negative 6x cubed. That eventually, after multiple doses of Lopetal, fell out of the problem, didn't it? Wow. Okay. Hey, doc, I'm feeling indeterminate. Infinity, infinity. Wait a minute. Cut them off. You know what? In this last one, we can do some canceling. Those x's cancel. Do algebra to the expression if you possibly can. Those x's cancel. This is just the number negative 360 over negative 480. And you gotta go, wait a minute, patient. I don't want to over-prescribe here. You're not indeterminate anymore. You're just the number negative 360 over negative 480, aren't you? Or positive 480. I'm sorry, there's not a negative sign there. I knew something went wrong. You caught it earlier, didn't you? That's 480x. I don't know why I put a negative there. Okay. But the point is, if those x's cancel, which they finally did, there was no canceling back here. But the point is, it doesn't matter what x approaches, the fraction negative 360 over 480, that's our limit. Oh, that'll reduce, won't it? Let's see, 120 will go both those. Negative 3/4. Now, wow, a long time ago, we talked about limits at infinity and how they related to horizontal asymptotes. And you might have been thinking all along about that. And here's what I would take you back to. When we had a limit at infinity, we talked about, we find the largest power of x in the entire fraction. Oh my gosh, are you kidding me? Which was x to the 5th power. And then we used the coefficients of those two terms to get our limit. I just wanted to show you why that worked back then. I remember telling you at the time, there's a reason why the largest power of x is so important, because this explains that every time you apply L'Hopital to this, those lower powered terms eventually disappear. The highest power of x is going to stay in the question the longest, and that's not a coincidence that the negative 3/4 turned out to be our limit. So you're probably wondering, how do you want us to do this question? If we get one like this, can we do it that old fast way, or would you like us to do L'Hopital? I'll be honest with you, I really don't care. I think obviously that makes more sense, it's faster, but I hope talking it through explained now why that technique works when you do limits as x approaches infinity. So there you go.